Welcome to Module C, Lecture 6. Module C was on trip generation. In previous lectures, particularly in lecture 5, we gave you several examples of erroneous regression equations to tell you what kind of problems may occur or what kind of mistakes people normally do while developing regression models. And then we started discussing some of the key characteristics of zonal based regression models. And then the two specific aspects we discussed, one is interzonal versus intrazonal variation. Regression models we actually prefer or actually we want more of interzonal variations, but as I said, sometimes problem may happen because one can find from the data that interzonal variation is relatively lesser and there is a significant intrazonal variations. Then the second thing what we discussed was about the role of intercept, the constant, and we said that constant represents basically unexplained component, and therefore, as far as possible we should try to make these constants minimum and if possible even to make it 0, if that does not distort the overall model. If there is a significant distortion in the model because we are forcing the intercept to be 0, then we retain those constant. In continuation to this various characteristics of zonal based regression model, so with these two issues which were discussed in lecture 5, we will continue and discuss a few other aspects related to zonal based regression model. So, the next point is about the null zones. Now, what is null zones? When you develop models, certain zones may not offer information about certain dependent variable. Say for example, house or home based trips may not be generated in non-residential zones. So, if you have purely non-residential zones, then the trip productions may be 0. Now, question is, so this kind of zones where which do not offer information about certain dependent variables may be called as null zones. Now, if there are limited number of null zones, say for example, a few cell values in the dependent variables are 0, then it may be fine because their inclusion may not significantly affect the coefficient estimates. So, you may not really bother much, but if there are more such null zones in the overall database, then there will be many zeros in the dependent variable cells. So, what will happen, that will actually may overestimate the accuracy of the estimated regression. So, that in that case one has to really think, and probably one has to think that to exclude the null zones from the database if their numbers are significant. If they are small in number, then there is no issue. Also, the other part, next point is a very interesting feature of zonal based multiple regression is use of zonal totals versus zonal means as variables. I can use, say for example, total variable, say maybe total car in the zone, or I can use car per whatever it is per household, then it becomes of course a household model, or you can rate the per household, per household also we can use. So, then maybe vehicles, number of vehicles per household. So, one is basically total vehicles or total cars, that zone wise that may be a variable, and in second case each zone what is the rate, that means what is the zonal means, how many vehicles per household. Or similarly one can say that total trips produced per zone, another case trips per household in that zone. So, the first case we are saying we are using zonal total or aggregate or total variable, and in the second case we are using rate or zonal means. Now, what are the implications? Before we talk about the implication, let us see that mathematically then what does it mean. If we are using zonal total, maybe we are representing the dependent variable as capital Y, and if we are using zonal mean, then let us say we are using the variable dependent variable as small y. So, either capital Y or small y for each zone. So, it is y I. Then you know that theta 0, theta 1, theta 2, these are the coefficients, and let us say zonal total, the variables are capital X I 1, capital X I 2, capital X I 3, like that, and when we are using zonal means, they are small x I 1, small x I 2, and so on, right. I have written it here. Now, obviously, if you say small y I equal to capital Y I divided by number of households H I in that zone, zone I. Similarly, small x I equal to capital X I divided by H I, number of household, and I have written also one error term, because obviously we are estimating. So, there will be an error. So, that error term, first case aggregate case model, we are saying capital E I, and in the second case we are saying it as small e I. Okay. Now, look at these two equations very carefully and tell me, are they identical? Are they identical? They may not be identical. What is then the fundamental difference? Fundamental difference is actually in the error term distribution. The distribution of small e I and small capital E I is not same. Why they are not same? Can you think? The answer is H I is also a variable. Suppose H I, if number of households in each zone, say hypothetically, is equal, then what is H I? H I is no more a variable, it is like a constant. Every value, every cell you divide by one number. So, that is not a problem. But in this case, number of households in zone 1, zone 2, zone 3, and like that for all n zones or k zones, right, for all n number of zones may not be same. They are unlikely to be different. So, actually H I is also a variable. So, the error term distribution will be different. So, I have written exactly for this reason that the models are identical except the error term, right. As the aggregate variables directly reflect the zone size, when you are using aggregate variables, the magnitude of the error actually depends on the zone size, because what will be your variable values or inputs, that will depend on how big the zones are. So, the bigger zones will obviously expect it to have higher value. smaller zones will have lesser value. So, the somewhere the error term in the estimate also actually is getting influenced by the zone size. Okay. Now, second case, what we are doing in the second case, we are actually dividing it by or multiplying it by 1 by H I or dividing it by H I, number of households, to make it rate. Once you do that, then the values, the bigger zones, bigger value, smaller zones, smaller value, the size of the zone does not really matter. So, this model is almost independent of zone size. I said almost independent because the size of the zone is not coming directly. Okay. So, that is why the error term distributions are also different. So, the first case you have to remember that if you are using aggregate variable, the magnitude of the error actually depends on the zone size, and once you are using a multiplier 1 by H I, that means using the variables at rate rather than the total, then you are making the model independent of zone size. Now, in the same way, what is also found, the aggregate variables when you are using in the models, they tend to have higher correlation than the mean variables. Now, this is again logical. If you think, it sounds logical. Why? Now, every variable, the bigger the zone size, every variable will be bigger, population also will be more, number of cars also will be more. So, every variable for smaller zones generally smaller, larger zone generally bigger. Okay. So, when you have more population, probably if everything else is same, you will generally find the more number of cars also. Of course, that is not that always they are perfectly, every variable has to be collinear, you will not get that as well. Okay. But obviously, because the zone size is going inside, the aggregate variables tend to have higher intercorrelation than the mean variable. The chances of such correlations from the data, right, will be really lesser when you are using mean variable or the rate, right. So, this is also another point what you have to bear in mind, and you have to be careful that you may get simply that two variables are collinear simply because you have used actually aggregate total. So, obviously, somewhere at the back end the zone size is actually controlling everything. So, these are very interesting aspects one has to bear in mind, and that is why just getting something out of the data, computer will tell you correlation value, computer will tell you R square value, right, but the interpretation is very, very important. One more interesting thing I would like to say about this zonal based model is the next point. Models using aggregate variables often yield higher R square. As two independent variables are likely to be more correlated, the bigger the independent variable values, the bigger will be the dependent variable values as well, right. Because everywhere there the whole thing is getting influenced by the size of the zone. So, when you develop a model, you may apparently get a higher R square value, but really that does not mean that your the model using zonal total, you are, because just simply R square is higher, you are getting a superior model than a model what you will get probably using the zonal means or the rates. Okay. Remember that the zone size again is playing a factor here, and actually giving that security, because of that reason you are actually getting a higher R square value. So, even what I am trying to say, you have to be very careful when you are developing model, understand all these aspects, and that is the reason why do not try to conclude only based on R square that my model gives better R square than his model. So, my model is superior, that is too simple a conclusion. Okay. Inside, if you have used zonal total and somebody has used zonal means, there is no wonder that the model with zonal total will give you higher R square. What is really certainly unsound, that what happens if we use a mixture of means and aggregate variables in the single model. Normally, I have also not come across such models, either people use zonal means or zonal aggregate. Okay. The last point is very interesting, where we are saying that even when the rates are used, zonal regression is still conditioned by the nature and size of the zone. This probably you will find that what sir told in the previous slide and sir telling now are contradictory statement, actually not contradictory in that sense. When we said that yes, when you are using a multiplier 1 by h I, you are largely trying to make the model independent of zone boundary, because you are using the rate, right. So, that is definitely true, but even then what we are trying to say that zonal regression is still conditioned by the nature and size of zone. Why we are saying this? Look at this example in the next slide. In the same study area, when 75 small zones were used, that means the study area was divided into 75 small zones, then the mean value of trips per household per zone came out to be 8.13 and the interzonal variance came as high as 5.85. The same study area, when we divided into 23 large zones, right, to represent 23 large zones to represent the study area, then the mean value came at 7.96 and interzonal variance came only as 1.11. So, does it not indicate that even when using the zonal means, remember that our value first, the value where I am indicating here, they are mean value of trips per household per zone, mean value. So, this mean value is also getting influenced by the zone size. When we are using small number of zone or large number of zone, the values are not same. More particularly, the interzonal variation is going to be very different. When you use 23 large zone, you get interzonal variation as only 1.11, whereas whenever you use 75 small zones, your interzonal variance came as 5.85. It increased significantly, and what we want? We actually want higher interzonal variance. So, our model will be good if the interzonal variance is high. So, that shows that overall regression, even when you are using mean or mean value of trips per household or essentially rates, right, then also the regression is conditioned by the zone size. So, that is what I made this statement. Even when rates are used, zonal regression is still conditioned by the nature and the size of the zone. So, what it tells you? That if we use more number of zones, then we can increase the interzonal variation. or variance. And in fact, we want, you remember that when I talked about several characteristics of zonal based regression, I said that intrazonal versus interzonal variation. We want interzonal variations to be more and intrazonal variation to be less. So, if I am going for smaller number of zones, then my interzonal variation is increasing. So, what it says? That go for smaller zone, and obviously then same area, if you are trying to make zone smaller, that means you are actually going for more number of zones, and that will definitely help you to increase your interzonal variance and reduce intrazonal variance. But then there are certain implications. What are those implications? First of all, you will end up having more expensive models in terms of data collection, calibration and operation. Naturally, if I am considering 23 zones or 25 zones and I am considering 75 zones, my data collection effort is not going to be same. When you take small zones, then you need much more data to represent all these zones in the overall study area in a proper way. So, your data collection, your even subsequent OD data collection, all efforts will be magnified like anything. The second is, you are likely to face greater sampling error when you also increase the number of zones. This is also, it goes like as expensive model, you go more, spend more to collect the data, spend more time, more money, overall more resource, and you are also likely to face greater sampling error when the so many zones you are trying to consider. So, for these two reasons, what appeared to be logical, that we make models which are independent of zone boundaries. Can we totally eliminate that zone effect? How to do that? So, if you start reducing the zone further, where we end up finally? What is the smallest unit? Household. So, can we just make the model then household based model rather than zonal based model? We started with zonal based model, we told you so many characteristics, so many things, and then reducing the intrazonal variability by increasing the number of zones. Implications also we told. What logically then comes out, that probably we can go for household based models to eliminate the effect of zone size in our model, and also to basically absorb or basically eliminate to some extent the impact of increase in the cost, resource, sampling errors and so all other issues, right. So, in a household based application, each home is taken as an input data vector in order to bring into the model all the range of observed variability about the characteristics of the household and its travel behavior. So, you take all possible characteristics, income, household size, car ownership and further additional variables, and then try to explain how the household trip making is happening. And once you do that, you know that in a zone then how many households are there, of what characteristics, and accordingly from the household based models, ultimately I will still come back and make my zonal estimates. So, end of the day I will still go back and try to say zone 1 trip production is so much, zone 2 trip production is so much, and like that. Now, if we have to then summarize this whole thing, remember that zonal based regression models are widely used. You have also typically so many variables, say residential density. say for example, value of land. This kind of variables you can use only when you are using zonal based model. But zonal based model has certain aspects which one has to understand. One is zonal total versus zonal means, then use of null zones, right, then intrazonal variability versus interzonal variability, right, then the value of intercept, and then what we found, if we try to reduce the zone size or make more number of zone, then obviously that helps us to increase the interzonal variations and reduce intrazonal variations, which is welcome, but we end up developing models which are more expensive in terms of data collection, calibration, operation, right, and also greater sampling error. So, then and still the zone boundary influence remains in some form or other. So, then what is really can be done, probably as an alternative you can use zonal based, instead of zonal based model you can go for household based models, right. And in that each household is taken as an unit or an input data vector, and then we try to take all different characteristics of household to explain or to relate household trip making behavior to the characteristics of household. So, with this I close today's lecture. Thank you so much.